Hello everybody and welcome to a brand new video, and today we're doing tutorials on GNS3, and our labs today we're on the third set for our GNS3 Workbench set for ICND1. So the last video was DHCP and the one before that was configuring two IPV4 routers. So now we've made it down to the third one, which is IPV4 address allocation. So I looked at our lab and our goals here, and what we're going to be doing is actually given a network statement, and we have to do subnetting and then configure those addresses to our interfaces and to do some OSPF routing. So actually the hardest part of this lab is knowing how to do subnetting, and unfortunately it just wouldn't be a good idea to try to teach you how to do subnetting in the middle of a lab video. I'm assuming that if you're looking at labs, you're trying to learn configuration and you already know how to do your subnetting, and if you don't know how to do subnetting, there's no way I could really teach it to you quickly and easily enough to cram it into a lab video. So what I will do though is I will do the subnetting. I'll run through how I do it and we'll get our answers, but I'm not going to go through the process of how I know that stuff. I'm assuming you've already watched subnetting videos, and maybe down the road at a future time I will produce my own how to do subnetting videos to help you along the way. So let's go ahead and read the lab goals here, what we have to do, and then we'll start doing it. The scenario is that we're a technician and there's two existing routers that are already fully configured for other sites, Acme 1 and Acme 2. Acme 3 is a brand new router that is not configured yet, and we have to configure it based on this criteria. All addresses are going to be coming from the 192.168.101.0 network, and that was a /24 address, and they've broken it down into a /28, so they subnetted it. We have a loopback 0 interface that we have to give the last valid IP address from the 0 subnet, a fast Ethernet 00 interface, getting the first valid IP from the next subnet, and then serial 01, getting the first valid IP on the last subnet. And then after we've configured the interfaces, we need to add all of them to the OSPF routing process, so that way they can communicate and be routed on the entire network. The routers' names are Acme 1, 2, and 3. The OSPF area is area 0. Clocking is already provided for us on our serial interface. Here's our password to get into the router. The subnet mask is the default mask, and here are the full IP addresses for each router. So Acme 1, here's fast Ethernet and 00 for a serial. Acme 2, and then what we'll be doing is Acme 3. When we're done, we can check our answers with the virtual PCs using the low check answer script. So we'll slide that aside, because on this particular lab, all we have to do is actually right here, already on the network diagram. So we need to do our subnetting first before we do anything else. We can't add the IP addresses to our interfaces until we figure them out. So I'm going to just grab a notepad document and start figuring this out. So our network statement, 192.168.101.0, that's our /24 network that we're going to be subnetting into a /28. I know that if I take 4 bits for networks, that's going to give me 16 networks. It's going to give me 14 hosts. And our block size, or magic number, depending on what you want to call it, is going to be a 16. So starting with 192.168.101.0, the next network would be .16, the next network would be .32, and I'm gonna copy and paste real quick to save us the time of doing all of that math, because I just did it right before the video. So here's our network ranges using that block size. We have the first network 0 through 16, the next one's 16 to 32. If we count them, there are indeed 16 networks here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So our math was correct when we said we'd get 16 networks by subnetting like that. The host, we have to figure that out by looking at the numbers here. The way I have it, the number on the left is our network statement. So this is the .0 network, this is the .16 network, the .32 network. We can't use the network's address as one of our IP addresses for a host, so we lose the number on the left. The number on the right is the very first address of the next network, so it's actually not part of this network. The last number in this network would be .15, but because .15 is the last IP address in that network, it belongs as the broadcast address. so we can't use it. So our usable range for this network would be 1 through 14, which is 14 addresses like we stated. The next one would be 17 to 30, and we would just carry that pattern all the way down to the end. I should put some asterisks there and explain this real quick. The way I do my counting when I'm doing subnetting is when I hit 256, I actually write 256. But in reality, when you're working with binary, the highest number you can get is 255. So what this really would look like if I wrote it out as an IP address, it would be 192.168.102.0. It would carry over. We went from 101 to 102. This is the very first network address, but this is the full next network of our /24 CIDR notation. This would be outside of what we subnetted to. So our usable range would be 241 to 255, with 255 being the broadcast address, so we can only assign up to 254. Again, I'm trying not to explode your brain too much. We just need this information so we can work on our actual lab. So let's go ahead and do that now. We can jump in there. We don't need Acme 2 or 1. We're going to do all of the configuration on Acme 3. Log in, enable mode. We'll start with our loopback 0 interface. So let's go global configuration mode, interface loopback 0, IP address. And it says it's going to be, let me read it in detail, last valid IP of the 0 subnet. So here is our 0 subnet, 0 through 16. The last valid IP is 14. So it's going to be IP address 192.168.101.14. And then we also needed to put the subnet mask on there. The way I do subnet mask is I take my block size, which is 16 in this case, and I subtract it from 256. So 256 minus 16 is equal to 240. So it's going to be 255, 255, 255, 240. Loopback interfaces should be up by default, but I always type no shutdown just because it's a good practice and I don't want to accidentally forget it one day. So loopback interface is done. We'll move into interface fast Ethernet 00. It says that this interface is going to be given the first valid IP of the next subnet. So we've already used the 0 subnet. The next one is our 16 to 32, and our first valid address is 17. So IP address 192.168.101.17. Same subnet as before, and no shutdown. Last, interface serial 01. It's going to be given the first valid IP address of the last subnet. And that's the reason you have to write out all of your subnets, because very common in all the exams and other testing situations, they're going to not just make you know the first couple, they're going to make you know what the last is. So you can either write them all out like this, or you can kind of reverse engineer it. Know that your very first classful network is this and go backwards. I can just go backwards from this and know that this is going to be the range of addresses going backwards. So the first valid address on there is going to be 192.168.101.241. All right, let's look at our interfaces. Do show IP interface brief. And we'll see all three of our interfaces are assigned with IPs, and they're up and up as far as status. So all the ports are operational. Next, we'll look at the routing table, and we'll see that the router only knows about the directly connected interfaces. So routing has not been configured for us. We need to add these interfaces into the OSPF routing process. So they told us that we're using area 0, which is the backbone area for OSPF. We'll go ahead and say router, I actually need to go to global config real quick, router OSPF1. And we can do the Cisco recommended network statement where we'll add each individual interface with its own network statement, or in this case, this is a great time to do the quick and dirty way, especially for labs where you want to add every interface in one statement. And that can be done with this network, and then all zeros, and then for the wildcard mask, all 255s. We'll put that in area 0. So you can see we have OSPF adjacency already. So we have formed a relationship. And that means if we go and look at the routing table again, we've picked up all of our OSPF routes. So now we should have full network reachability through our OSPF process. And the way we're going to check that is to load up these virtual PCs. All right, and we're going to load that answer script. So load check answer.vpc. All right, so the first test is going through. Second test is also going through. And the third test has gone through. So it looks like we have perfected that lab and we have all of our answers correct. Otherwise, these pings would have failed. So that was it. It was a pretty easy lab. You just have to know how to configure a very simple OSPF and how to assign an IP address to an interface. But the catch is this particular lab did not give us the IP addresses to assign. We had to figure them out on our own. And that would be where the mistakes would be made, if any. So we did really good with our subnetting. I would like to explain to you guys in more detail one day exactly how I do these calculations in my head pretty quickly so that you can do really good in your exams, because there's going to be, especially in these beginning exams for IC and D1, a lot of subnetting to do on your test. So I just want to remind you this was Vicious. I hope you guys enjoyed the video. We'll be back shortly with another lab, and I'll see you next time.